What does it take to cut a ship into two halves? To strip down and reassemble a giant plane? To overhaul the world's longest high-speed train? It takes hundreds of professionals, expertise, precision, and courage.
It's never been done before.
Pushing everyone to the limit.
It is surely a challenging job.
Now on Mega Pit Stops. She's the most modern warship in the Danish Navy, the HDMS Absalon. The flexible support ship is 137 meters long and equipped with high-precision weapon systems, from torpedoes to machine guns to anti-missile weapons. Thanks to its smooth and angled outer skin, the Upsilon reflects only a fraction of radar radiation, making her extremely difficult to detect. The tracking systems of the warship itself, on the other hand, are highly sensitive. The Navy vessel offers space for 2 helicopters, and its flex deck is suitable for everything from a hospital to tank transport, depending on the mission. 2 separate engines, each of them with 11,150 horsepower, make the Navy ship remarkably fast and maneuverable. The bridge, replete with the most sophisticated technology and packed in bulletproof steel. For all this to work perfectly when deployed, the Upsilon has to be docked every 5 years for a major overhaul. For this mega pit stop, engineers subject the entire ship to a complete reconditioning. The most complex of all the processes, removing and checking the marine shaft device, which in effect means cutting a hole in the ship to remove the rudder and propellers. The bow thruster will also be removed, including maintenance. The team will also overhaul the sonar and replace the bulkhead doors. And then there are the upgrades. The technicians install a brand new UV filter system for cleaning the ballast water. Painters give the entire ship a new look. Time frame for all pit stop stages, just 5 weeks. Orskov Yard in Frederikshavn, North Denmark. The crew prepares the 215-meter-long dry dock for the arrival of the huge warship. Thomas Majin assumes command for the docking procedure. The special construction of the naval ship is a challenge, even for this experienced dock foreman.
Here we have the ship. There's the rear end, and there's the front end. And there's the bow with the Sonar Dome. If the weight rests on that, everything in it will be smashed. So that would be really expensive.
Yeah. Under the water are bracings, wooden blocks on which the ship will later rest. Thomas has to position the Upsilon so that the fiberglass Sonar Dome is exactly in the gap at the front bow. His only method of orientation, the meter indications at the dock's edge.
We've done this before. It should work, I hope.
Now it's time. Tugboats are pulling the Upsilon into the dock because even a high-tech Navy ship is far too big to maneuver itself in such a confined space. Only 6 meters on each side. Dock foreman Thomas Majin directs the tugs.
Everything's fine for now.
Take a look on that side. We're getting a little close to the wall.
First, Thomas positions the Upsilon against the dockside wall. It's the only way for the front tug to be able to get out.
We'd say 2 meters for a position.
Karsten, are you ready for landing?
Yes, I'm nearly ready.
2 meters, then we are in position. We stopped.
Okay, good. Then just slack the rope again. We have slack.
They got it. The tugs leave the dock. A critical moment. If their propellers whirl up too much water, the Upsilon will start rocking and crash against the dock wall.
Slowly, slowly, slowly.
As soon as the tugs are out, Thomas Mayen begins the process of fine positioning. First step, close the gate. Then 3 powerful pumps with an output of 178,000 liters per minute drain all the water out of the dock.
It's important that the vessel is in the middle of the dock when we start to lower it down.
The narrow streamline hull must now be centered exactly above the bracing. The marking lines, Thomas's most important orientation aid. Another decisive factor, the correct distance to the end of the dry dock. Only then will the sonar line up with the gap. The endpoint has been met. Solid wooden beams prevent the ship from tipping over as soon as all the water is out.
Okay. Do we have everything over here?
About 2 hours, then the 64 million liters are out of the dock. The first hour of truth ensues. Is the sensitive sonar dome exactly in the gap?
There's the nose. It looks good. Now I am happy. That should work.
Thomas Mayen masters the first challenge of the mega pit stop, at least at first glance. The workers immediately begin the preparations. Meanwhile, the dock foreman checks once again whether the 5,000-ton ship and its sonar dome are indeed free of damage.
Everything looks really good. It's all good. So, yes, perfect. No damage or anything.
The clock is now running. In just 35 days, the Upsilon is expected to set sail again. Project manager Martin Christensen is responsible for keeping to the schedule. In the end, every day of delay means one thing for the shipyard: exorbitant fines.
First, I go down into the different work areas and safety areas and make sure it looks like it should.
And there's good reason for that. More than 200 pit stop points are on the so-called dock list, which is the Danish Navy's order form.
Right now, I'm on the way down to the engine room where several tasks have to be done.
The warship has 2 engines, one for each propeller. If one motor fails, the other one takes over. This way, the Upsilon remains maneuverable at all times. Martin's team is to install a filter system in one of the engine rooms. First, the team kills all germs and bacteria in the ballast water. If the warship has to dump ballast while in action, the filter will protect the ecosystem.
The whole system and piping changes and the connections will be rerouted. That will take a while. The most important thing is that we are certain that we establish a place for the systems that are printed out by the ship owner.
Just one of the many challenges for project manager Martin Christensen and his team. And just one of many upgrades. In the next 5 weeks, technicians will bring the Upsilon up to the state of the art. They'll replace technically obsolete systems with brand new ones. Like this AC unit. Only if everything works perfectly will they be able to keep to the tight schedule. Nevertheless, it's important to take one step at a time. First, the team gives the Upsilon an overnight cleaning. Then, it gets down to the real work. The greatest challenge of the mega pit stop? Overhauling the marine shaft device. It's made of 2 multi-component drive shafts. In the first step, the crew dismantles the rudder blade and propeller. Then, they pull out the 21-meter-long tail shaft. To get to the intermediate shaft, the team cuts a 6-meter hole in the ship. It's the only way they'll have a chance of getting the thing out. The work is totally dependent on a truck crane at the dock. The marine shaft device is located under the ship's hull, and the fixed dock cranes simply cannot reach it. No one knows just how serious the damage could really be. During an initial visual inspection, divers did not detect anything. Only now will it become clear in what condition the Upsilon truly is, and what repairs the team will have to do in just 35 days.
We deinstall the tubes, then have an air compressor to clean the axle shoe. Then we take 2 axles out of the stern tubes.
For this, the bronze propeller blades first have to be removed, at more than a ton each. The Upsilon has variable pitch propellers. This means the propeller blades are hydraulically controllable and are able to change the angle of attack at any time. This makes the Navy ship extremely fast and maneuverable, a decisive advantage during deployment. At the same time, the team dismantles the rudder blades, and they weigh quite a bit more, a proud 6 tons. The rudders of the Upsilon are Becker flap rudders. The adjustable flap at the trailing edge makes the warship extremely maneuverable. Another critical factor in combat.
The rudder will be lifted into our shop and set up on a larger space, and also cleaned up and washed.
Even if the propeller blades appear to be very solid, the workers must be extremely careful. Just one dent is all it takes, and the part costing several €100,000 is ruined. The propeller blades are sent to a specialist company for inspection and maintenance. In the late afternoon, they've managed to disassemble the propeller and rudder on both sides. Meanwhile, another task is waiting for the truck crane, this time at the very front of the ship. Here sits the so-called bow thruster. It allows the crew to shift the bow of the ship sideways during a war maneuver. The crane operator carefully lowers the 1,500-kilogram bow thruster. 5 years of naval service since the last check has left its mark, which is why specialists will disassemble every single part in the days to come. Another extremely important item on the list for the mega pit stop: the sonar. Naval officers use it to locate submarines and mines as far as several kilometers away. Underwater, it is the Upsilon's eye and ear. Its construction and other external details, well, that's a military secret. But this much is clear. On the high seas, the dome around it is filled with water. The sonar's sound pulses shoot through the fiberglass envelope at speeds of up to 2,000 meters a second. Thanks to its cylindrical shape and its position at the front of the bow, it provides the sonar technicians with a 360-degree all-round view of the ship. To make it work even better during deployment, the technicians dismantle the sonar and give it a super state-of-the-art upgrade. But not just under the ship. The crew also works simultaneously in every corner of the vessel. Project manager Martin Christensen's job is to monitor all the work being done, several times a day. It means he covers a lot of distance.
In the end, it will be many kilometers, and then there are a lot of stairs. I think it's about 1 kilometer per round.
His next stop, the engine room. The technicians there are in the midst of preparing the installation of the ballast water treatment system. The problem? Indeed, there is no more room for the complex system of filters and pipes.
There are special components, and here is the foundation, and we have to install the whole thing and then connect it.
The main filter may already be in place, but the UV lamps for killing the ballast water bacteria also need to somehow fit inside. A total of 75 team members work simultaneously at this mega pit stop. The warship possesses 2 sets of all its major systems, but this also means 2 times the work for the shipyard crew. In the event of war, their responsibility also includes maximum security. The result of the interior check shows that 10 of the bulkhead doors have slight weaknesses, and that means they need to be replaced. Otherwise, when the going gets tough, the Upsilon will be in serious danger. Because the hull consists of 16 water and gas-tight sections connected by bulkhead doors. Thanks to this system, if the ship is hit during combat, only one of the areas fills with water. This means the ship remains afloat. If even one of the doors leaks, the ship could sink. To be on the safe side, the workers even replace the door frames. It's all work that takes time. Day 4 of the mega pit stop. One of the most complicated work steps of all is about to happen: removing the propeller shafts. Meanwhile, there's a 6-meter long and 1.5-meter wide opening in the hull. But it's the only thing making this maintenance possible. The most difficult step in the process: removing the 21-meter-long end piece of the propeller shaft. The plan? Using chain hoists. Pull out the tail shaft piece by piece. The problem with this is that the propeller shaft is hollow and therefore unstable. Too much tension or pressure, and the multi-million-euro component will bend. Mechanical engineer Jorn Rabjerg manages the highly complex removal process. His team must carry out each step precisely, both in terms of sequence and timing.
There's an oil distribution system ring that should also be taken out. And we have to be careful when we take it out.
Only after removing them will Jorn and his team know whether the drive shafts have been damaged at all, and if so, to what extent. Time for final, critical instructions.
Carsten, those bolts over there are supposed to lie on the scaffolding here. We have to find them.
Okay, we'll do that.
But before you put that on... Yeah, that's fine. Perfect. Now I have to go to the other side.
Jørgen's team works with 4 chain hoists at the same time in order to exert as little concentrated pressure as possible on the propeller shaft. Meter by meter, they pull the shaft backwards. Technician Karsten Dovada knows exactly what to look out for.
We do this work with the propeller shafts very often. We have to be careful, otherwise we'll ruin what's inside here.
This applies in particular to the tail shaft mounts. They contain extremely sensitive bearings that run around the propeller shaft.
We are pulling on carefully, so it comes out further.
The further the team pulls the shaft out, the greater the risk that it will bend under its own weight of 22.5 tons. Half of the job has been completed. Now the dock crane takes over. But that doesn't make it any easier.
The problem is, it hangs like this because it's so long.
The diameter of just 40 centimeters is very small in relation to its length. This makes the tail shaft extremely unstable. After a good 3 hours, technician Karsten Dovada and his colleagues leave this problem behind until they have to install the shaft again later.
We are happy.
But what condition is it in? At this very moment, still completely unclear.
We're measuring the axle now. And if it doesn't have the right dimensions, we'll have to do something about it. But it looks very good. But we'll only know tomorrow when we measure.
This also applies to the tail shaft on the other side of the ship, because that's next. Meanwhile, technicians in the engine room are already preparing to remove the 8.5 meter long intermediate section of the propeller shaft. Martin Christensen's team is getting good time with the Navy ship's mega pit stop. Duration of the tail shaft removal, just 1 day.
We have definitely completed one of our bigger projects, and it has gone better than expected, so we're happy.
But the crew is only just now transporting the propeller shaft parts for their critical inspection. Everyone hopes to reinstall them in a couple of days, at the latest. Meanwhile, about 60 kilometers south of the shipyard, more specifically in Aalborg, specialists are working on another important part of the warship, the bow thruster. First, they overhaul all the parts. Then, technicians Benjamin Vammen and colleague Morten Bjerring reassemble the rudder. Both hope it works, potentially even better than before.
We've packed the outside, then we are about halfway. We will have to be a little careful. Then we will have to make sure the bearings are inserted properly, and then it is together.
Time for the test. The rudder is placed in the housing. The gearbox inside transmits the power of the engine to the bow thruster propeller.
This is the contact surface for the gears, and we have the bearings out of it, and it looks a little worn in the profile.
During assembly, the technicians first heat the individual parts with electricity. Initially, this causes the metal to expand. It contracts again when the assembly is complete. The result, ideally, everything is 100% waterproof. The only thing left is the cleaned and polished propeller. It's made of aluminum bronze with an especially saltwater-resistant alloy. A critical moment. Technician Morten Bjerring connects the propeller with the control system.
Det kontrollen.
This is the control. There is a connection to this here, which has a sensor on it, so you can see from up on the ship where the propeller is. This is also a really important piece of equipment, so it should be fastened.
Time for the function test. The technicians connect the bow thruster's hydraulic control system to a warship simulator machine. Looks good at first glance. And at second glance as well. The variable pitch propeller can steer thanks to the control of the individual propeller blades in every direction, defined by the warship simulator.
The results of the test show that the blades are moving fine, and we just have to have it finished off and ready for the client. It was a successful test.
Test passed. In just a few days, the workers can reinstall the bow thruster into the warship. In the meantime, the ultimate test of the mega pit stop is coming up at the shipyard, measuring the propeller shafts. None other than Peter Poulsen performs this one. He and his team are the specialists for marine propeller shafts worldwide.
I'll place the rollers on the axle, where it's prepared for the test, and then we turn the axle around. Then we put a clock on, and then we measure.
A test in which every single millimeter truly matters. Peter's special dial gauge shows whether the propeller shaft is deformed, and if so, how much. This eminent authority compares the results with the target values. Maximum permissible deviation, 3 millimeters, and this at a total of 10 measuring points. The further the dial gauge pointer moves, the worse it looks. And the result?
I think the axle is crooked, so it needs to be taken up and straightened.
A catastrophe. Based on the results, the expert suspects that the shaft has deformed due to excessive acceleration during a military maneuver. The results of measuring the second shaft are still out.
From port side, this axle here, in the second measurement, is a little better than the other.
A little bit better actually means almost as bad. And for the shipyard, as well as the Navy, it also means repairing both propeller shafts. Apart from the costs, it is estimated that this will take about 3 weeks. The delivery date of the Danish naval vessel is in serious jeopardy. Time for a crisis plan.
Well, it isn't clear where we should go. But the axle there, that is a critical area. So we have to look at the pilings. So now, we should go to the meeting room, and then we can discuss what we should do.
The problem? If not repaired, the propeller shafts could soon damage the drive itself. Project manager Martin Christensen has to have them repaired, and he has to absorb the impending loss of time as much as he can. The subsequent repair of the propeller shafts takes place in Hirtshals, just 45 kilometers away. In the first step, specialists stretch the propeller shafts. Then, a laser applies very fine layers of liquid metal to compensate, as much as possible, for the remaining imbalance. Technicians measure the propeller shafts repeatedly. It's a game of time, and nobody knows how it will end. Halftime at the mega pit stop for the Danish Navy ship. While the shaft is being repaired, project manager Martin Christensen pushes forward with all the rest of the work still to be done, such as the check of the 245-meter-long anchor chain. At least here, everything's fine. Installation of the new bulkhead doors is also making good progress. The crew is already preparing the frames for the 170-kilogram doors. They have to be 100% airtight. It's the only way the bulkheads can prevent the ship from being flooded in combat. To be absolutely sure, technician Kim Skolbæk Sørensen and his colleague are testing each and every one of them.
That leads to our living area. If there were to be an accident here, it is critical that we can seal this off completely so nothing happens to the people inside. It is a safety feature.
For the final test, Kim first cleans the rubber seal thoroughly. Then he puts ordinary chalk on the door frame. And then closes the door. Done.
And there we have the results, 100% tight. If there had been an area without chalk, we would have had to do something to correct it. But you can see the chalk all the way around, so it is exactly how it is supposed to be.
The idea behind it is as simple as it is ingenious. If the fine chalk dust becomes visible when the door is closed, the pressure is high enough. And it proves, in an emergency, not a drop of water will get in.
This is the simplest method, but it is always 100% correct. No water gets passed if this test has passing results. This is what experience tells us. Now the hour of truth. It looks fine. Chalk, chalk, chalk. Yes, perfect.
This door also passes the test. Now technician Kim and his team continue the test on the other doors. If he makes a mistake, the whole ship could sink extremely quickly, if attacked.
We have now checked all the doors with new seals, and we have run the chalk test like we usually do. There is nothing wrong with them, so they need no further repairs. Otherwise, we would have made repairs. Everyone is happy, no water is getting in. That was the last 100% test of seals.
The specialists in nearby Hirtshals are still working on the propeller shafts. The decisive and hopefully final step: inspect the metal for any damage that may have occurred during the work. Materials tester Jan Hedemann Algonsen uses what is known as a dye-penetrant inspection.
I'm looking for tiny indications on a white background.
The color red serves as an indicator.
The next thing that happens is it has to sit for 20 minutes and penetrate the material.
If there are inclusions or cracks in the metal, the paint is absorbed and then sets. After 20 minutes, the team cleans the propeller shaft millimeter by millimeter. Now, the last, absolutely critical step.
Now we are putting on the developer. Yeah, right down the neck.
The so-called developer is a fine-grained powder. It makes the smallest residues of the red color invisible, thus indicating defects. In the worst case, the propeller shaft requires time-consuming reworking. And indeed, the developer shows faults. The team immediately marks the critical points.
We found some indications of it, so it has to be repaired. And in a few days, it should be done.
A serious delay. The ship is supposed to be complete in 10 days. The mega pit stop would then also be over. But even if the shaft is finished in time, the installation is extremely complex and complicated. First, the 8.5-meter long intermediate section must return to the engine room through the tiny opening in the hull. One bump by the workers, and the freshly serviced propeller shaft is damaged. The best-case scenario is that the team affixes the bearing and closes the hole. Only then can it mount the end piece, propeller, and rudder. Mechanical engineer Johan Rabjerg uses every remaining minute to make the most of this shrinking window of time. His dock crew installs the intact intermediate shafts in the ship.
Yesterday we set the new stern tubes in place. After installing them, we put the middle axle in place. The next thing is to assemble it in the machine room.
But to do this, the workers have the mammoth task of getting the 8.5-meter long and 6.5-ton heavy intermediate section back into the engine room. For technician Simon Bostrup and his colleagues, this, like everything here, is a major challenge.
The hardest thing right now is to get the axle in, and then we need to assemble some bearings.
Clearance when feeding in the propeller shaft? Just 10 centimeters. Weight and length make the whole thing even more difficult.
I have done it once, but normally when we pull axles, it is not this caliber at all. We pull out the propeller shaft itself. This is really special.
At full power, the propeller shaft operates at 1,500 revolutions per minute. Monumental forces are at work here. Simon and his colleagues, therefore, spend hours fine-tuning each bearing to the millimeter. This process alone, including sealing the hull, takes several days. The Navy ship's delivery date is creeping closer and closer, and there's still no sign of the repaired propeller shaft. Meanwhile, teams are repainting the Upsilon with a meager 4,000 liters of fresh paint. The time has now come. It's day 30 of the mega pit stop, and there's almost a standstill. Technically, the Upsilon is supposed to leave the dock in 5 days. While the crew works intensely under the ship, carrying out the work still possible in this state, everything above deck is almost ready. The brand new ballast water treatment system has since been placed in the engine room. The installation is complete, including 50 meters of newly laid pipes. Everything is going according to plan, except for one thing, which is going to be tough on the crew, despite all their successes. They'll have to wait. 3 days later, almost all the work on the ship is complete. The team is still hoping that the propeller shafts will arrive on time. For project manager Martin Christensen, all that remains is a final check of his team's finished work. Despite all the complications, he is confident that the ship will be delivered without a significant delay.
It is a big problem for us that we had to wait for the axles. It delays a lot of other work, but as soon as we have the axles, I'm sure we'll get the job done quickly.
Then, a crucial message arrives. At least the first of the two drive shafts is back. The starting shot is fired. Dockmaster Thomas Mayin immediately initiates installation of this sensitive part of the warship. And this is at least as complicated as taking it out.
We hope everything is ready. When the crane is ready, we'll try.
First thing to do, get the shaft out of the hull as quickly as possible. And make sure there's perfect cooperation between the dockmaster in the vehicle and the operator of the indoor crane. Almost half an hour for 10 meters. Under these circumstances, perfect. Now the dock crane takes over. Thomas Mayin double checks every suspension.
I think this one's longer than the other. It's a little hard to see.
All right.
A job against time, and yet with maximum precision. Even just the tiniest error, the repair work that costs millions would be a complete waste.
Now we just need to get it down in the dock. And in.
Tension remains high. The team waited almost 3 weeks for the propeller shaft. Now, everything has to proceed perfectly.
Now that we can get the shafts in, we can start some of the work that has been waiting on the installation. Until now, I'm satisfied. We've quickly brought the shaft down into the dock and expect to have it rigged in shortly.
The next step is no less delicate, because not only the propeller shaft itself is sensitive, but also the bearings inside the mounts. If they hit each other too hard, all the work will have been wasted, to say nothing of the time pressure. Carefully, piece by piece, the team pushes the shaft back into the ship. Finished. In the shaft tunnel, technician Simon Bostrup and his colleagues then have to reconnect the tail shaft to the intermediate section.
You really have to be careful when putting in the axle, that you don't damage anything. These are expensive things we work with, so we are careful.
This is because the bearings and seals prevent water from penetrating the ship along the propeller shaft. All this only works if every part fits exactly to the millimeter. Then, in the early evening, success. Well, at least 50%.
Now we're done.
The first propeller shaft is back where it belongs.
The axle is in and we didn't scratch the rod or anything. We are very pleased. It has exceeded our expectations. It is a major milestone on the project, so we are very happy that we got the axle in. Now we are halfway there. We just have the second axle to go.
The only thing left: mount the propeller and the rudder, all several tons of them. And then, 2 days later, the hour of truth. Propeller shaft number 2 finally arrives. The team is only slightly behind, but they're still able to keep the loss of time within limits. Now it's down to one last sprint in this race against time. Day 37 of the mega pit stop. With a delay of only 2 days, project manager Martin Christensen and his team are completing the final work, and this despite all the problems. He's proud of what his people are able to do, right up to the last second. 75 people overhaul a complete high-tech naval ship in 5.5 weeks, working 26,000 total hours, 8,000 square meters completely renovated, painted, and finally, state-of-the-art. From propulsion to sonar to the airlock doors, from innovations such as the new ballast water filter system to the drive, the Upsilon is ready for its next mission. Well, almost. Just one thing left to do: the test run. Project manager Martin Christensen also has the final responsibility here.
We're ready. I was just out checking the last of my outstanding tasks. Everything is ready for launch.
The float test. As simple as it is crucial. It will soon be clear whether the team has closed and welded all openings and holes to 100% water tightness.
Everything should go just fine. There is a tiny risk, but not much. It has to be watertight. We hope so.
The critical moment. The Upsilon floats at a water level of 7 meters. Meanwhile, inspections are performed inside the huge naval ship. Just one small leak, and the team has to abort the check. Two hours later, the dock is completely flooded, and the warship holds tight.
We just got word from the ship, and everything is sealed. Despite the problems we have had during the project, we have been able to deliver nearly on time. And we are ready for the client to take over the ship.
The mega pit stop. It's over. After 37 days, the Upsilon is ready for deployment once again. The tugs take the warship back out to sea. And she sets off from there to the next top secret mission.